And a very good afternoon, everybody, and thank you for joining me today and my friend Jonathan, where we'll be going through some of the cool new sensors which we can put onto the M300 RTK sensor. So some of you might not know me. I am James Pick. I am the Business Development Director at Coptrz, mainly working with the survey and construction industry. And we're joined today by Jonathon Brindley, who is the owner of JB UAS, who has a whole host of sensors which can be used onto the M300, which offers that little bit more than what you can currently get from DJI in terms of the sort of the inspection and survey industry. These are kind of your next level up in terms of what we can start using with drones and getting some really, really great results from it. So I'm going to hand you over to Jonathan now. If you do have any questions, though, please put them into the chat or into the questions tab, and we can answer them for you at the end. So without further ado, over to you, Jonathan.
Thanks very much. Thanks very much, James. That's great. Yeah. Welcome, everybody. Like James said, I'm Jonathon Brindley. I'm owner of JBus, and let's move on to the first slide that I've got to share with you today. Let's have a look. Let's try again. Right. So we're official UK reseller for SPH Engineering. I think a lot of you would know that as UGCS. We have contact with the guys every day at UGCS, talking about different projects, trials, demos, you name it. We're involved with them a lot, and we're talking at multiple levels. So what we actually do is we're not just interested in selling kit. We're interested in developing and commercializing solutions, so drone solutions that will increase the effectiveness and efficiency of what you're doing in your everyday operations. So it's really about finding those solutions that can really help you, really make the difference. So we've got working on projects, not just in the UK, we're working on projects. At the moment, we've got, like I said here, we've got projects in the Middle East. We're looking at projects in Canada as well. So we are, we are talking about projects not just in the UK, but also abroad. Now, we are talking to the sensor manufacturers directly. So, for example, on projects like GPR and Magnetometry, we would be talking to the sensor manufacturers to ask the questions that we can't that we need answering, that we can't answer ourselves immediately, or we need a little bit more help. And to that, on that point, what I'll do is I'll just switch to this slide here. We should have been before, but this just gives you a sort of indication of how things are working, and it's just a snapshot of how we're operating. So I would like to think that 90% of all the inquiries or the questions in the inquiries can be answered from ourselves. The UGCS product management team, they would be answering the majority of the remaining questions that we can't answer. But then, dipping into these sensor manufacturers to just get the final bit of data that's needed to give you the confidence to make the right business decision. So that's really just a little bit about how it works. Let's go back. Yeah. So I thought I'd just put a slide in here about how Coptrz and JBus are going to work together in the future. We signed a deal, sort of like a long-term cooperation agreement, let's say, early on at the start of 2021. And we're just really trying to increase the awareness of geophysical sensor systems and how they can deploy and how they can be deployed in the marketplace. And we're very wary that sometimes people know that these solutions exist, but they find it harder to access and how to actually put them together and deploy them. So hopefully, between Coptrz and JBus, we're able to sort of make that a lot more accessible to you, or make these geophysical sensors a lot more accessible. And you also know we've got a lot of support in the UK now to actually help you choose the right solution for you. It's a very symbiotic relationship. It's working really well so far. So, like I said, the main aim of the aim is to bring these solutions, make them more accessible to you guys. So just the first thing I wanted to just touch on here in terms of, before we get into the sensors, was just a little bit about UGCS Pro. I think a lot of you might know UGCS Pro already and know that it's actually it's kind of the flagship product of SPH Engineering, and probably used in the majority of when automated flight's involved. used by the majority, well, a large percentage of commercial users. But one thing that I need to emphasize before I do actually get into the sensor, the integrated system or the sensor system, is that the integrated sensor systems all use UGCS Pro, and it's really the backbone that allows the sensors to be so effective. So that's the key thing to remember and to take from this slide is really that all of the integrated sensor systems are really it's part of an integrated package with UGCS Pro as the heart of that, which allows you to set up your automated missions and make sure you get the data right for your sensors. Make sure you get the right distance between your swathes, and also make sure that you get the right data you need. Another thing that I just wanted to touch on is that if you do want to know more about UGCS Pro and you would like some training on UGCS Pro, we do actually offer a 1.5 day. We offer a day remote training, but you can also have a half day practical as well. So we can do that in the UK. So the practical will be in the UK with a UK instructor, somebody who knows UGCS Pro inside out. And like I said, this is a certified and approved training course as well. So it's something we can support Coptrz with. I'm quite happy to do so. So that leads me to sort of the integrated systems. What I was really keen to do was to give everybody on the call just a quick snapshot of what we're talking about when we talk about an integrated sensor system. So we talk about them all the time, but in terms of when we talk about an integrated sensor system, a UGCS, what we're talking about is the following, and what you can see in front of you. So you've got we've got the compatible drone, and it could be DJI, or you could have a Pixhawk with sort of like Hydrography software. You would have your sensor, which you can see in this point here in this picture is an R3 magnetometer. Going downwards, we've got a terrain following radar, which connects up via an RS-232 into the top of the Sky Hub. Very easy connection indeed, I must say. We have the Sky Hub, which is your onboard computer, and we'll touch on that next. So I'm not going to go into too much detail, but that's the little box that sits on the side of your drone and allows you to connect all the different sensors and geotag stuff. We've got the CPM, or the custom payload monitor software, which integrates into UGCS Pro and takes over some of the functions of flying the payload. The other two bits of software we've covered. We've already discussed UGCS Pro a little bit, so we know that UGCS Pro is the sort of the core part of the integrated system, and allows you to automate the sensor mission. But what people might not know is that you've also got a DJI companion app, which allows your laptop to talk to the controller, and that allows the pilot, when he's actually when he's flying his drone, to actually visualize where the drone is, as he would do if he was sat on the laptop. He won't have some of the telemetry that you'd get on the laptop, but he would certainly see where the drone is in its mission, and he would be able to follow it. And I'm going to show you a little bit more on that in just a moment. So really important to talk about Sky Hub, because I would say probably 2 in 10 questions I get is always, what is Sky Hub? So Sky Hub is your onboard computer. Sky Hub is great because what it does is it's talking to the A3 controller in your DJI drone, let's say the M300 in this case, and it's providing the drone with allowing the drone to fly in what's called true terrain following mode. So if you're flying a magnetometer, let's say like an R3, and you want to keep an AGL of 1 meter, then it's the TTF mode, the algorithm within the Sky Hub, that's allowing that to happen once it's all set up correctly. It's collecting all the data as well. So it's geotagging the data. It's also providing some of the download of the recording of data, including telemetry, into one simple file that you can download and use. It's also allowing all the different download types. So depending on what sensor you're going to have, it's going to allow you to download the different files for SegWide, for instance, CSV is another one, and so forth, depending on what your needs are. It's also providing power to, and you can see that it's actually there for your sensors. So, depending on which sensor you're going to have, it's going to provide power. Here, for example, the Falcon will have a connection coming out of there directly into the Falcon, the methane detector, and you'll see that later as I show you. So the SkyHub is really, again, it's a key part of the integrated system. Important to note that you will run out of battery before this thing runs out of memory. So 30 gigs of memory, you've got plenty of memory to go at. So that's a good thing. So also important to know why true terrain following mode and why bother with it. And as you probably know, there's a number of reasons why you wouldn't want to, but one of the main ones is that barometric pressure can't really be 100% trusted. I mean, this is an extreme example on the right-hand side, absolutely extreme. But the point of the matter is there are issues with barometric pressure, and sometimes, ideally you want to fly upwards. When it senses something's wrong. But what happens if it flies downwards? If you have a break in telemetry, then there's all kinds of complications that could come into play. But if you do have a TTF radar and it's in the SkyHub's controlling it, that everything is going to be okay. Especially when you've got an expensive sensor on the bottom, what you don't want to be doing is going into the ground. So you can set your AGL depending on what sensor you are. So like I said before, if you're flying 1 meter, a magnetometer, you can fly it at 1 meter. If you're flying a GPR, you might want to fly it even lower. You might want to fly it at 0.5 meters or 0.6 meters. So that's entirely up to you. Also, what I mentioned before was that you can customers can actually, they can ask for a different algorithm to put into SkyHub. That's quite an important thing to remember. But also here we've got another flight mode. There's another flight mode that we can go into as well. But the other main one that I want to talk about is grasshopper mode, which is great for bathymetry missions where you've maybe got a lot of seaweed, or it's very hard to do normal passes. You maybe just want to, what you can do with grasshoppers is, as it suggests, is just dip down into the water, come back up. Once you take your reading, come back up, move to the next spot, dip down, come back up and move to the next spot. It's really useful when you've got really, really conditions. So that's also another good thing about the true terrain following. It's not just about true terrain following, it's the radar itself. And it's got, using, in combination with SkyHub, it's a very clever piece of kit. So once you've got your system, you've bought your system and it arrives, it goes without saying, between ourselves and UGCS, we're going to be wanting to help you to set it all up, make sure it's configured properly, so you can go out and actually fly the thing. Once that's all done, then what you really want to know is, how quickly can I set this thing up? How easy is it? So that's what I really want to go through now. So yeah, exclude the idea of uploading software. I mean, you've got to boot up your software. Maybe I could have rephrased that a little bit better, but you're booting up your software, you're booting up your companion, you're getting all the software together. Once that's up and running, and you've got your UGCS Pro running, you've got your controller all set and synced in, then you've got your custom payload monitor also booted up, and you can see that actually in the picture in the bottom right here. You can see the blue boxes. That's the custom payload monitor. That's the bit that's that's going to take over some of the flying conditions of the payload, and it does override some of the settings in UGCS. But again, you get this in the training. It's not the thing you need to worry about just now. So quick and simple integration. Just a really quick snapshot here. We can see here we've got our SkyHub. We've got our connections coming in from the top of the OSK from the M300. You've got your laser Falcon, which is the methane detector, and we've also got the TTF here as well. So what I want to do now is just quickly go through this and explain to you how quickly you can put this together. You've just got it out the back of your van. You want to know how quickly you can get this going. So we've got the SIP2 here. So how quickly is it to set up? You've got one connection, like I said to before, on the top of the OSK in the top of the M300. This has got two cables. One cable is an RS-232, and it's going to go into the top. And you can see this in the top right-hand corner. That's where the data is going to go, and it's where all the telemetry is being passed. That's going directly into the SkyHub. And then we've got the second cable, which is going into the power input on the side of the SkyHub. Now, you can't get this wrong because the two cables are connected into one connection. And the one connection you can see It's that one in the top left-hand corner. So very simple and very easy to connect. Simple fastening as well in the bottom left-hand corner. All this stuff, all the fastening comes with the kit you get. So it's all been tailored. Step two, step three, connect up the Sky Hub to the TTF radar. We've already discussed how important the TTF is and what it gives you. But again, simple connection, RS-232. You can see it sitting right next to the cable coming from the drone, just to the right of it. And yeah, real simple connection, seconds to connect up. So the last step to talk about is just how it's connecting the scope to the sensor. Well, this depends on what sensor you're going to use. We've got different connections to Bathymetry, let's say. You could be using a USB if you're using Falcon for a methane, or indeed you could be using the RJ45 or LAN, as some people call it, for your GPR. So it all depends on what kind of sensor you're going to use. As you can see down the right-hand side, we've also got another cable. That's the power output. Sky Hub has a power output, which is really handy when you're trying to power up sensors. And sometimes you can actually get rid of batteries, like, for example, on the R3. You don't actually need the battery on the R3. We can actually power it from the Sky Hub. So it gives you a few more options. So having a power output is really good. So different sensor systems. So I really want to home in on the M300 RTK and really give you some understanding of what's available and what's not available. So at the moment, ground penetrating radars not quite ready, but they're coming soon and they're in testing. So we've got a light version being put together at the moment for the M300, and I'll show you some pictures in a minute. So hopefully that will help you sort of visualize that. Echo sounders available now. The M300, as you know, has got a fairly good payload. So yeah, it can handle fairly decent dual frequency echo sounders without a problem. And you can still probably get about 25 minutes flight time. So that's pretty good. Magnetometers, both the R3 and the R4 are available. R4 is a brand new sensor system. Sorry, there is a brand new sensor system for an R4 sensor system. It's a lighter version for the M300. Again, I'm going to show you that in a minute, so you can get a good sort of understanding of what that might look like. Metal detectors. This is really just for the M600 Pro at the moment. And it's mainly, as you'll see a bit later, it's because of the way that it's configured, the way that it needs to be sort of dropped off the arms of the M600. Who knows in the future? But at the moment, it's not something that we are looking at. Methane detectors are available right now. You can use the methane detectors, the Falcon. And again, I'm going to show you that in a minute as well. And the last one, which is probably my favorite, if I'm going to be really honest, is a sonar with what it can do. And that is kind of, I said available. It's on its way. It's very close to being available, and probably a little bit of work, but certainly available on the M600 Pro. If you have an M600 Pro, this system is available right now. And what you'll see is when we go through that at the end, because I think it's the last one that we go through, you'll just see how good this is. This sonar system is, and actually this could offer you, depending on what you're doing. If you're in civil engineering and you're looking at structures underwater, or you need to. I mean, this is really good. It's a good step in the right direction. So just want to quick go over ground penetrating radar a little bit. I could go on in it forever in a day on this subject, but I don't think I want to. Not right now. Everywhere we get to, we need to leave. But you can see some good examples here that I've put in here of the development that we're doing on the M300. So we've got some new radar GPRs that have been developed for the M300. So giving some options for the M300. Like I said, we've still a little bit of time to go on that. So yeah, just bear with us and we're going to get there. So GPR at the moment, I'm afraid, because of the weights involved, we're talking between 3 kilograms and 5.34 kilograms for some of the heavy geophysical units. So yeah, it's M600 Pro at the moment, but we've got to think about alternatives, and I'm sure that's going to come in time. There are other drones coming on the market, and I'm sure UGCS will be on top of that. And so, one of the things some of the things I keep getting asked are, why airborne GPR? What's it actually going to give me? What's going to do for me? Really, you can get in certain conditions, over certain terrain, you can get higher efficiency or better efficiency. It can still be really highly accurate, and you can program in, for example, the lines or the sways that you want and the distance between them. You can cut with the TTF. You can monitor. You can control the AGL. So between the AGL and the swathe and the GPS RTK, you can really get highly accurate positioning. And that's what, so you get really consistent data input. That's really, I guess, what we're trying to say here. Also, it's automated. So, theoretically, you should eradicate human error. You can just get it to, with the UGCS Pro, you just tell it to take off and once you've set the mission up, it'll do that all automatically. And then it will come back and just sit, and it will just land where you've told it to land. So, fully automated. And, again, not so much human error. But I think I've talked about quicker surveys, and that's to do with, you can get it right first time, basically. It's no human error. You can fly these things in more hazardous areas. I mean, things like, in some cases, you could sort of have it down slopes on the sides of roads, or maybe on railways, or other hazardous areas that you don't really want anybody, human going into. It might be that there are other things in place. It might be that it's the soil is contaminated, or depending on what GPR sensor you're going to use, it could be that it's a bit boggy or whatever. So there's lots of reasons, and we can go into more detail with these in time. But okay, so that's kind of GPR in a nutshell from sort of reasons why. Here are some GPR specifications. These are a few of the standard GPRs that we can provide. We're going all the way from 1,000 megahertz, which you'll probably use for things like soil analysis, where you need high resolution, but not too deep, probably top 30, 50 centimeters. And that's about it. But you need really high resolution to see the differences. Things like, grassroots down, soil depth, just below that, just to see how things are going. All the way through to utility detection with the 500 version, 500 megahertz, which is, as you can see there, the minimum diameters that it can detect as kind of a rule of thumb. Then going all the way through to the SC40, which is going to give you, maybe up to 30 meters penetration. Again, this depends on what material it's going through. And there are a lot of things that we need to think about when we're choosing a GPR. So that's something that I can go into a little bit, but not too much detail. But so we're going through very high resolution GPRs that just do a small depth, all the way through to longer wave GPRs that will go quite deep. You have to select the right GPR for the application, and it is really on an application basis. These are some units here, but I like to really get into it and really understand the application before specifying anything or giving guidance or advice. So just a few considerations that I wanted to include in here. Important to note here on the top right-hand corner, that's actually a radar team radar team GPR, longer wavelength GPR, and that GPR is good for bathymetry. So you can use, for example, if it's no ice at all, you just fly it over. If there's ice, it will still go through the ice. You wouldn't do that with an echo sound. You wouldn't drag it along you wouldn't be able to get it into the water. But the GPR, the longer wave GPR, is really good for getting through ice. Also, it's very good for when you've got high turbidity, whereas echo sounders really wouldn't be able to cope with that. And the GPR is a very good alternative to that, and can still give you a great 3D representation of the topography of lake, for example. One thing to note, or very important thing to note about using GPR and topography on bathymetry is you cannot use it in salty water. because the signal is absorbed, because of the salt is absorbed, because of the situation that you get when you have salt in water. It just attenuates the signal pretty much very quickly. So freshwater bathymetry, it's great for. I mean, really good, depending on what you want to do. But yeah, it's really, really good. And not only that, it will see below the surface as well. GPR doesn't just stop, depending on what the depth is. It won't just stop at, like, say, 4 or 5 meters, 4 or 5 meters at the bottom of the lake. It will keep going through soft sediment, harder sediment, until it hits something it can't go through, or the signal is no longer powerful enough to come back. So that can give you a really good sort of like slice of what's actually underneath that. So very useful. So some things to think about when you're thinking about GPR is that, unlike having a cart-based GPR when you've got it on the surface and literally just a few centimeters off the ground, you're not really. It's not. A lot of the signal strength is going into the ground. It's not the same when you've got a drone that is flying at, let's say, 0.6 or even 1 meter above the ground, or AGL. So half the signal strength is going to be lost, but just from reflection from the surface. And you need to bear that in mind. It does reduce, as we saw in the last slide. You might be getting over 40 meters normally from a certain GPR, but as soon as you stick it in the air, because it's going to go through that air and the reflection that you get, you're probably only talking 20 to 30 meters. So you really need to think that through. It needs to be part of the makeup when you come to think about the project. The other thing that we found in testing, and well, this is obvious as well, actually, because it's just the way that these heavy soils work, but things like it's important to note is that heavy soils such as clay and loam, unless they're absolutely bone dry, the GPR is going to really find it hard to get through. Certainly the higher megahertz systems will find it really hard. And as soon as you introduce water, saturated ground, it's a showstopper, as I said. But yeah, so it's really need to think these things through. From the technical perspective, we call it an RDP less than 9. We don't need to get into what that really means, but just to say that dry, sandy soils, where the signal can move quickly and without being sort of slowed down, if you like, and attenuated, are brilliant, because you get pretty much a lot of the signal just going in. That half the signal that is getting it is actually going through. So dry, sandy soils is absolutely ideal for GPR. So there's lots of conditions where it's not sand, it's sandy soil, and it's really good for that. So in a nutshell, high frequencies give a better resolution, but small objects can be detected. So utility detection in the right soil conditions, that's great. I mean, you can see fairly small pipes. You're probably talking 10 to 15 or 100 to 150 millimeter diameter. You can really find these utilities in the right soil conditions. And lower frequencies are better for depth, mainly. More geophysical studies where you really need to see the depth of sediments. So yeah, that's the difference, really. Higher frequencies, not so much depth, but can pick up smaller objects. Lower frequencies, longer wavelength, you're going to be able to pass that signal through deeper and much deeper than you would with a high resolution, high frequency. Again, this is by application, so it's really, if you think that GPR is going to be able to do something for you, then yeah, we'll have a chat, we'll talk about it, and we'll look through the options. So I just wanted to quickly touch on data analysis here. So within all the packages that you get from UGCS, you do get, there's sort of free issue, you're going to get GeoHammer, and this is what I call it sort of QFR. It's a QFR package. It's quick fire results. It's something where it's a package where you're out in the field and you want to know, have I got the right data? Have I got enough of the right data? So it's really being able to put the data into the software quickly, There's not that many analysis tools that you can use, but there's enough to see, have I got the right data? Have I got enough of the right data? So you're able to quickly see, am I getting what I need to go back after this flight and get some good results from, do some good processing, get some good results from that processing. And that processing is done in what, in a more robust package like Prism 2. Prism 2 is offered to customers within the packages, and that gives you lots of different tools that you can use. And again, that's training that we can give you as well. So it's not, don't get me wrong, it really helps if you've got a background in you've done some GPR in the past, but it's by no means an end game for you if you haven't, because our training is pretty comprehensive. The training actually on GPR is, I think it's the only full 2-day GPR, airborne GPR course in the world, I believe. And on top of that, you do, as part of that, on top of that, you do get a lot of support around using the software. So there's just an example here in the bottom right corner. This is just a standard kind of picture, the profile that we show. And it's just showing you there a fairly large pipe there. I mean, it's probably something in the region of 10 to 12 inches. And you can tell that because of the kind of flat curve you're getting. And the hyperbola that's there is quite an open and flat representation. If it was a much thinner pipe, I don't know, something like 2, 3, 4 inches, let's say, you'd expect it to be the width to be much less, more top to bottom. Okay. So hydrography. I say hydrography loosely, and we've got a few things that we can do under up our sleeves. So here, bathymetry with echo sounders. I've said plus GPR. We've kind of covered that a little bit, but I might just say a little bit more about that. Sound velocity, turbidity, salinity, and flow speed. Some of the things are available. Some of the things are in working. So again, it's just a case of if you feel that we could help you in these areas, then please come and talk to us. We do have a good supplier, quite a top supplier of this kind of kit, who is very good at this. Just note here, it's quite an important picture actually, because what this shows you is, and again, this is a question that I get a lot from people buying TTF for bathymetry. The question that I get is, does the radar, the TTF radar, does it work well over waves? And the answer is yes, it does. And then that's mainly because of the cone. The actual area, the surface area how the radar works, and the surface area it covers when it takes its reading, and it takes a kind of its fancy algorithm inside there. It's taking the average of that surface area. So even if you've got a little bit of a wave, let's say not massive waves, but if you've got quite big wave, fairly decent waves there, the TTF should still give you stable level flight, depending on what AGR you've set, and that's been shown to be the case in a lot of work that we've done recently. I mean, this particular shot was actually shot in the. I've got to get this right. I think it was the Red Sea. So it was shot in the Red Sea. Let's just say that it was shot in the Red Sea, and they're getting fairly decent waves. So just the TTF will work on water for bathymetry. In fact, it's very good for bathymetry. So why use a drone for bathymetry? Well, there are going to be small or shallow areas that you can't get a boat in there. You wouldn't want to, you might not be able to get a boat into a certain area. You might not even actually saying that you might even be able to, wade in because it's just a little bit too deep. So there are some things, or maybe there's, it's soft sediments underneath. So there's that small or shallow areas. That's a good reason why to use it. Hard to reach locations, so you've got new points of entry. You've seen it yourself when if anybody goes fishing, you go fishing, you get a weir, and you've just lost something, and it's just around the corner, but you don't know how to get down there. So that's a really good way. In that case of you don't need to fight your way through the brambles. You can just get your drone out, get it around the corner. You can get it into some really hard to reach places. You've got, like I said here, you've got this grasshopper algorithm, which is absolutely ideal for bathymetry, the way you can dip down and come back up, go to your next spot. You're taking out mechanical debris, seaweed out of the equation, because you can work your way around it. You don't necessarily need to pull this echo sounder through the water and through the weed and through all this other stuff. So that's a really good thing to do. Some other areas: drinking water reservoirs for obvious reasons, and then we've already mentioned that in high turbidity GPR is actually really good. So again, we've got an option for that. It's fast to set up, easy deployment. You don't need a boat. You don't need, there's other ways that you can eradicate the need for a boat. Good repeatability, because of course we've got UGCS. In cases we've got UGCS Pro. You can set it to go, and it will just go, and it will do all the it will do the flight all automatically using GPS RTK and using its AGL radar. So really consistent, good repeatability as well. So you can compare the data over, do the same mission over and over again. And of course, good maneuverability as well. So just some reasons there of why you would use a drone with bathymetry. So ECD DO52 eco sounder. I've just put this in here as an example, really just because it's kind of it's a good package, dual frequency, quite heavy, but still looking, like I said at the beginning, still going to be looking at with the M300 RTK, still expecting around 20 to 25 minutes flight time. This thing will give you not only topography, but it will also give you, like I mentioned before, soft sediment to hard sediment as well. So you'll be able to see that soft sediment thickness. It's connecting directly into SkyHub. I think I mentioned that before, and via the ICE232. And we have on the system itself, we do find you do have a possibility of flipping a switch and having the SkyHub take out data that he thinks that the tilt is out of sync and will give you bad data. There's a word of caution on that, because sometimes you can switch this switch, and it's an option. Switch this switch, and you can take quite a lot of data away. So it's something that you really got to think about carefully when you do, if you're going to do that. Needless to say, tilt and pitch are data points that are carried from that sensor into SkyHub, and it's put down in the file so that you've got that data. So you can go afterwards in process, and you can make your mind up what you think your threshold is, and do what you want with the data. So kit weight 2.3, but so it's fairly heavy. Two modes of data. You've got the standard NEA, I think people know, 0803, and you also get this full echo data as well. Sort of segue for HydroMagic software or any other type of software. So we're covering off pretty much all the bases, all the kind of data outputs you would need. We are providing, whether it be CSV. I mean, one thing that I would mention here is I get a lot of people calling me up about point clouds. Yeah, the system will be able to give you a point cloud per se, and you'll be able to use that data. The other thing that I just wanted to mention, if I remember what it was, oh yeah, that was right. If you are going to use, what I would say is, what we found is, don't use the CSV for the raw CSV for your XYZ data. It's best to take it into something like HydroMagic, clean it up, and then export it for XYZ for use in different systems. So just a little bit of bit of a tip there. So magnetometers and magdrone. Magnetometers, magdrone R3 and R4. I'm not going to talk about magdrone. I'm not going to talk about MagArrow today. It is a sensor that we do cover. It's really, at the moment, it's an M600 system but you can use it on other drones as well. But it needs a fairly big width to fly it carefully. So I'm just going to concentrate today on the magdrone R3 and R4, which we do have experience of and some good results from. So So here's some really stunning pictures. I think you saw this one earlier, the Magdrone R3 and the M300 RTK. Really good for both the M3, both the Magdrone R3 and the Magdrone R4 are really good for detecting UXO. They're good for detecting utility pipes and cables. And I've also just recently read a really good article on investigating coal deposits. So that was quite interesting. I think it's a census case study. So that was really interesting as well. But I think in the main, a lot of there's lots of people out there looking for a good UXO solution that is going to give you good results. And I know there's a lot of question marks over that at the moment. And I hopefully I can clear at least one of them up in the next slide. So, as I mentioned before, with the Magdrone R3 from Sensis, it does have its own battery pack, but we can eradicate that battery by plugging in directly from the SkyHub, because we have that our power output. So that's one option that we can do. Magdrone R4 has its own rechargeable batteries. It's different, slightly different setup. We're able to with the R3. We're also able to provide data so GPS data to the sensor. So we can also provide sort of like an additional cable that will help you with that too. So there are some options that we can integrate the sensor a little bit more. What I would say is that both in the case of the R3 and the R4, they do their data recording internally. So it's not coming like some of the sensors like the Falcon methane detector or the GPR. We're not geotagging the data in SkyHub. We're really, when we're flying these units, we're really, for the most part, flying it for the TTF. We're flying it for to keep it at 1 meter AGL, so that we get that consistent collection of data. The main differences between them, I think it's pretty obvious, is that with the Magdrone R3, you're getting 2 Footscape on 1 meter, giving you between 1 and 1.5 meter swathe. And then the Magdrone R4, and I'm specifically talking about the new R4 M300 variant here, 2.5 meter swathe, but you can get a higher resolution by folding the bars in from standard configuration, which is 50 centimeters between each of the sensors, to folding those in to the middle and getting 25 centimeters parting. So it gives you, you're able to detect smaller objects. But again, it's there's a lot of parameters to be thinking about than just the size. So weight-wise, unsurprisingly, the Magdrone R3, 1.2 kilograms in weight, just over 1 kilogram, and your larger system, it was 3 kilogram. Now, I need to hold my hand up here and say that I haven't checked the new weight of the R4. I think it'd be considerably less than that now. So, again, that's something that if anybody has any questions, and I can certainly I can give you that answer. But it's certainly going to be a lot less than 3 kilograms. The other thing, and one quite important thing I wanted to touch on, was that I have a lot of questions from companies in UXO talking about noise levels that they've been getting on different drones, particularly actually from the M210, and to some extent, and some people have been talking about the M600 as well. What we can say is with good confidence is that through tests that we've done on the M300 RTK, we found that we're getting noise levels that are above your 3-4 nanotesla, which you would like to get ideally for for your raw data when you're doing your UXO surveys. We're getting a bit more than that, but what we are finding is when we're using software like Magneto, we can, using the Sensors data download tool and also some other tools as well in Magneto, we can actually take out a lot of that high frequency noise. So, you know, so a lot of that noise. So we're able to take out the noise that you would associate with these motors from these drones, and to a point where you can actually you're getting pretty clean data. So that's something to really bear in mind, that the M300 seems to have, it seems to be offering something that really, you know, it's a step change from for example, on the M210, where it's been quite high, and even trying to get rid of a lot of that noise has been a bit of an issue. But certainly with M300, we're able to do quite a bit, and it's probably the 200 hertz sampling rate doesn't hinder that. Let's say that kind of really helps. So a quick slide on just some understanding really of magnetometry and how what to think about, and that is just to think of you've got in a nutshell, you've got a much better chance of finding something hidden if you're closer to the ground than you would be if you were further from the ground. And this is just a really good example, because what this does, and this is actually from Sensors data tool, and what this actually shows you on the left is that on the right, I think that's actually from Magneto. But what this actually shows you is, by being closer, just by simply being closer to the ground, you can really increase the effectiveness or the ability to detect objects under the surface. And this kind of I guess in a way is why TTF is so important, because true terrain following allows you to keep that distance consistently over the ground, and do it safely. So you can see at the bottom, there's hardly, we've got some peaks there, but on the right, but certainly I'm talking about the bottom right picture here. Certainly on the right hand side, we detected something. On the left, there's something there. There's some red, but we can't really see too much. That's at 3 AGL. Now, when we drop that to 1 AGL, there is a significant difference. So it just underlines the fact that true terrain following really does provide, it does provide more capability to detect using magnetometers. So that's really just a sort of a really brief message, basic message on how a TTF can be a real benefit. Just wanted to put a few data, a little bit more data, some real data. Again, this is a census study that was conducted some time ago, but it's as real as it's ever been. You can sort of see on the right-hand side. I wanted to give you some real understanding of what you can and cannot. I know this is only one trial, and there's a lot of parameters, but it does give us a good feel for it. Both R3 and R4 tested, and they weren't far off from each other as far as the data is concerned. They were quite close, in fact, in terms of what they detected and what they didn't. But what you can see here is that there seems to be a kind of a size or a massive object that doesn't get detected at a certain depth, or it doesn't seem to pick it up, and that's because there is. And I can say that, like you can see on the left here, 1 kilogram or less at more than 0.5 meters, it seemed to be problematic. It seemed to be a little bit of an issue there. Now, that's just what was found in the data. Other than that, as I've said here, that was the 20%. Other than that, 80% of all targets were found up to get down to 8 meters and 100 kilograms. So it just gives you an understanding. So the idea of this is just to give you an understanding of possibly, what the considerations are, what you can and maybe what you can't detect. If you wanted to find a drawing pin at 2 meters, it's just not going to happen, or a nail at 2 meters, it's not going to happen. So it's just to be a little bit of understanding for those people that are new to magnetometry, don't really quite get it, thinking about it, what they could do. Could they use it to detect utility, main pipes in fields or whatever? You've not really thought about it, but it's an area of your business that you're thinking about. These are the sort of things that we would need to, you need to keep in your mind, and when we're thinking about magnetometry. So just a quick little bit on the data analysis tool with Sensors data tool, which comes unsurprisingly with the magnetometer when you buy it, and it allows you to see not only some of the data, but the data, and also to the flight path as well. As you can see in the top right hand corner there, you can actually see where you've flown your drone, and as you move over that flight path, it will show you where you were, and what were the results you were finding, what they were there, so it will track it along. You can also, in Sensors data tool, you can also do some filtering as well, which is quite useful. Again, this isn't the time to go into the detail of that, but just to say that this is all covered in the training, which is, like I keep going on, is fairly comprehensive. You go into something like Oasis Montage or Magneto, then you've got a lot more options of what you can do. You can see things in 3D. It's endless, and I'm only just getting to grips with it, to be honest with you. And that's after a year now. So it's a really great tool. But we've got, the UGCS training that is really good on this in this kind of area. They've had a lot of experience of doing this now, even with the M300 RTK actually. So yeah, there's lots of questions I'm sure we'll get, and I'm pretty sure we can answer them without a problem. So I just wanted to touch on metal detectors, because it's a fairly new sensor that we've had recently. It's probably in the last 6 to 8 months that's kind of like been out, and I don't want to go too much into the detail of this. Again, it's not something that is really ready for the M300. You only have to see, the way that it's dropped below the M600 to see why that might be. It's a really heavy weight. It's not going to be carried by the payload of the M300. So there are lots of reasons why, unfortunately, this is really an M600 Pro or equivalent drone, running on an A3 or a Pixel Kaji Coptrz type firmware. So I want to just quickly jump from this, and I let you read this information, but I really want to jump to the next slide, because I think this is really the slide that just really gives indication of how successful this system has been. And also, I want to talk a little bit about PASS 128, because I think it's important to note. I have been asked about by a couple of people now about why can't I use this, or why can't I use this for surveying pipes, and I have to explain to them my understanding. If anybody can give me more understanding on this, that would be really good. And like I said, I'll go into a little bit more detail. But the results that we've got from the metal detector have been very warming, I must say, down to sort of 2 meters in depth. It's been very, it's been hitting the mark, let's say. It's at 100% hit rate. So 2 meters and below, ferrous and non-ferrous, it seems to pick the objects out without too much of an issue. So again, really quite an innovative active system for ferrous and non-ferrous items. Now, I did say I just want to talk about PASS 128 just quickly. For those people that are surveyors, probably already know this already, but from what I can gather within PASS 128, reading it, is that PASS 128 is fine with you using passive techniques, GPR and other passive techniques, such as magnetometry. But what it isn't too keen on you doing is using active survey techniques, such as this metal detector. The only way that you would be able to do that, and this is my understanding, and like I said, reiterate, if you have better information, then please let me know. I'd love to know. Is that within PASS 128, unless you are inducing within a pipe system, then it's not possible. You can only use an active system within a pipe system, and that's my understanding of reading the survey techniques that they allow. So yeah, really open to hearing more about that. If anybody's got more information on that, please, get in touch, via Coptrz, or maybe even ask a question. So methane detection, again, some really good pictures of actually some testing of the M300 RTK and the Falcon sensor. This is a sensor I'm really heavily involved in at the moment. Actually, got some really exciting surveys coming up that we're doing. In a way, groundbreaking kind of methodologies. And it's not something that there will be a press release coming out soon, so I don't want to say too much, but involves quite a large operator, and we're hoping great things from it. So, but in the interim, yeah, we've got this system called Falcon Program. Program are the manufacturers. Again, we're in a deal with Pergam to support them with sales in the UK. So again, very close relationship with the manufacturer, as we do with Census, as we do with Radsys, Echologger, and some of these others. So we, again, just to reiterate, we've got good close relationships. It's an eye-safe laser classification. So again, perfectly okay for flying. It gets power directly from the Sky Hub, and I think I mentioned that earlier. We power it via the outlet of the output power of the Sky Hub, and we connect in the data with the USB. Sky Hub in this case is geotagging the data, so it's bringing the data in, it's geotagging it with the RTK for your processing later. So that is something that is being done within Sky Hub. I don't need to tell you this. The M300, what a machine this is. I mean, incredible machine. The Falcon's not very heavy. The whole payload together is probably not far off a kilogram. This thing can, give you a good sort of like 35, 40 minutes flight time. Doubling what you would expect to get on the M600. Well, maybe a little bit more than M600 with the Falcon, but not that much. So you can do a lot of surveying. This thing can go really quickly. You can fly at many meters per second, and it will still give you good readings. You can fly it over dangerous areas, so things like bioenergy plants, where you've got to be careful around some installations such as gas terminals and other oil and gas infrastructure where you can't actually fly over the top of it. But again, it can. You can fly it into some places, and there is an option of tilting the radar, tilting the laser. Sorry, radar, tilting the laser, so we can do different things with the laser. We're flying roughly about 20 meters above the ground, 20 to 30 meters. I think you get your best results at around 20 meters, and we're using the laser itself is measuring in ppm times m. And what that actually means is that whereas with a person you would walk along and you would take a reading at A, you would walk along a bit more and you take a reading at B, you take a reading at C, and so on, and that would give you a picture, but it would only give you a picture to about 2 meters. So by firing the laser from 20 meters, let's just say 20 meters, the laser, the energy is absorbed by methane. The laser energy is absorbed by methane. It's a very well-known process. So the readings that it gets back are on that basis, but it does it through the whole of the column. So if the column is 20 meters, it's ppm times m. Now, let's try and visualize that a little bit. That should make a little bit more sense. So what we're able to do with the meter is measure above 2 meters. In fact, up to 20 meters, obviously, because that's the height at which the drone is situated. But what it does do is it gives us a much better understanding of the plume of gas, not just the reading, but the plume of gas, and also the extent of it. And if you're flying from A to B, and you do that a number of times, you can quickly find out the body, a good understanding of the volume, not quantification, but you're able to see where that plume of gas is and where the bulk of that gas is situated. And that's very useful on landfill sites where you have you've got different containment, mechanical containment technology for keeping the gas within the landfill, especially if you're using it for generation. The more you lose, the less money you make. And also, of course, it's a methane release. So, as per Paris 2015, sooner or later, someone's going to be knocking on your door and saying, "What are you doing? What ISO standard are you following?" So, what things have you got in place to show that you're getting to grips with, So, being able to understand where this gas is really, really important. And the ppm meter is, although it's not going to give you volumetric quantification, and that is something that, as I mentioned earlier, is something we're now working with people on at the moment. That's going to, hopefully that'll come soon. I can't say exactly when, but soon. Then this is a really, as an interim, this is really good. It gives you a really good understanding of where that methane gas is. So here's a couple of nice pictures that I thought I'd include just to give you some understanding of what we're talking about. So on the left is a plume map, and that's just there to give you an understanding. You can make out that's a landfill site, it's sealed over. It looks like it's got sealed over with sand. There will be a containment mechanism within there, and there are a few red parts on there. And I'm not saying this is the case because I don't know it, but these areas, these 3 or 4 red areas where you find the concentrations quite high, they could be where the containment is not working. And so it allows the landfill operators to really make good decisions on where their investments need to go. If they, in line with their sustainability policies, they need to be showing people that are living in these areas that they're doing what they can to make sure that that they're looking after the mechanisms that are holding in the gas and that they're doing the right thing. So it's a really good visualization of what's actually going on their site. On the right hand side, this is an example of I think this is an example from Belgium, actually, Fluxus, I think. But this example of readings, I mean, what you can do, you can see here where the high readings are, but what you can do in the software that you get, it's very similar, it's like the equivalent to the data tool you get from Sensors. It's like that download tool you get, and it gives you some basic tools that you can analyze the data with. You can actually set in the Program suite, you can actually set what I call background noise methane limits, or threshold, let's say. So you fly around, you take some readings of the background methane, you find it's at a certain value of ppm, it's pretty consistent. You pretty much know that if you fly down that pipeline, in this case, this is a mains pipeline, underground, you fly down there, if you get readings that are, much higher than what you'd expect or what you've been getting on the base, sort of like standardized, normalized data, then something's quite wrong. And so the great thing about these systems is you can, with the right permissions, you can automate the flight, make sure you've got all your RAMs in place, obviously, but you can fly these missions or, autonomously. You get repetitive, consistent data. So the software, the UGCS Pro, will allow you to fly that Falcon doing in the same place over and over again. So you can compare data sets with quite high accuracy. And that is really quite a powerful tool. So just a few applications here. So I think a lot of you would be aware of these already. So, just a few of the ones that I've mentioned already. I mean, as we all know, things like anaerobic digestion is becoming huge in the UK. I mean, it has been for a number of years now. And you can see these as you go, you drive down within rural communities. You see them, they look like, they'd be better off on a Greek island. They've got a dome shaped, but they're, apart from they're not blue, but but you can see them. There's lots of them. In time, they may be in an area where, these gases, they need to be on top. And again, it's a business area where you might think, well, actually, I could, there's a lot of these sites around where I'm from, where I live. I could get there quite easily. I could keep my costs low. I could get one of these systems. I could provide them with the service. I could go over, and that's really, you could, and that's you can keep that data, of course, and compare it. You can do the same mission over and over again, so they know they're getting a consistent, they're getting consistent service, and they're able to compare apples to apples, of course, which is really, really useful. And then you've got things like gas processing plants, compressor stations. We've mentioned oil and gas. Again, depending on where you are, there are some RAMs and there are requirements that flight requirements, what you can and cannot do. But look, on the whole, these are the areas that I kind of identified as being, potential areas for business. So, as I said before, this is probably my favorite device of sensor. I suppose I shouldn't have a favorite, but it is. I think it's just because it's quite, it's really innovative, and it's quite, I don't know, it's just got something about it, the whole idea. I think it's, I think it's maybe because I grew up with Stingray. I don't know, but anyway. So this is the drone carriage side scan, and this is quite an impressive piece of kit. I have actually seen a trial of this system, and it blew my socks off. So this system is a sonar. It's based on the Imaginex sonar system, but tried and tested all over the world with police forces, search and rescue teams. It's just used everywhere. Everybody knows it. This is a system that has been put together, and at 300 kilohertz. So you got two frequencies here: 300 kilohertz and 850 kilohertz. Depending on where you are, you can use a different frequency closer up. Use another frequency for being further away, so you just get the outline, but you're not quite sure something's there under the water. It might be 8 or 9 meters away from where you're flying. Your sonar picks up something, you're not quite sure what it is, but then you can switch, go and have another look with better resolution, and you can then start seeing outlines of things. And I'm going to show you some examples of that in a minute. Quite impressive, I must admit. Really fast to set up and deploy. It can be flown manually or with UGCS Pro, so you can automate the flight. Let's say, I don't know, something falls into the water. Somebody says something's falling into the water and nobody knows if it's there or not. You can just set the drone up in literally 2 minutes. You've set up a mission. The drone is set up. Off it goes, and it does a complete survey of that area, and sees if there's anything down there. The other good thing about this system is it was designed with HYPACK in mind. So those that are involved in marine will know HYPACK really well. It's one of those tried and tested packages that everybody uses really. And it gives you a lot of options. So just a little bit about the logic behind this system and what it's trying to do. So what does it really do? So if let's say you had, let's say it could be just some couple of examples. It could be a bridge that's got steel structure. It's sub under the water, so you can't see it, but there's something wrong. Maybe something slipped. You want to go and assess it, but you don't know how dangerous it is down there because the sharp edges and so on and so forth. That's not something you'd want to get a diver in straight away. So what the sonar can do is it can go down there, it can have a look, and give the divers some context, or indeed just give somebody some context to say, I think that's something huge. Something's really moved down there. We need to do something about it. You're probably thinking about, but can you see, what resolution can you see? Can you actually see bits of steel? What can you actually see? Well, I'm going to just about to show you now. Before I do, one thing that I do want to say is that although this comes with the side scan sonar, there's lots of other attachments that can be put on as well, and these can be talked about. Other sonars that can give you more capability. So there's lots of options for search and rescue, search and inspection of bridges, jetties, anything that's in the water, below the waterline. Maybe you want to see large, maybe something like scour. There's been some rubble's moved, or this system is really good for that. Great for civil engineering companies that really want to get a good view of what's going under there before they commit anybody in an unsafe environment. So I said I would show you some resolution, and that's what I'm exactly going to do. What kind of things could you expect from this? So here you can see, so just a couple of examples, but I could have put 4 or 5 in here, but you can see the resolution that it's able to pick up. This is actually a sunken boat, and what it's showing you is the individual timber frame, and on the bottom you can see an actual structure that has fallen into the water. So something that was subsurface on the bottom of a bridge that supported the bridge, but had actually had rusted and fallen away, and therefore the structure was actually unsafe. So it was actually collapsed, but nobody could. There was maybe some vibration or something. People were picking up on it. Might be something wrong with this, but this system was able to quickly be deployed and could quickly go in there and see straight away that something was really, really wrong. And in that sort of situation, that bridge is not being used. Everybody is not coming on this bridge anymore, and you're able to maybe save lives, and also you've just given great context to divers who may need to go in there and fix it or retrieve stuff. So again, safety, speed of deployment, effectiveness, a really incredible system, really great system, really innovative. You can also see using this system. You can also see you can see the bottom of the actual like say river channel. You can see any obstacles that are in the channel, and you can see ripples in the channel. There's lots of things you can do, and if anybody has got if you think there's an application where in construction, civil engineering, where you think actually this is pretty good, we'd like to know a little bit more about this, then that's something, obviously, get in touch with Coptrz and we can sort something out. So getting towards the end of the presentation now, but I just wanted to end on and say something about the resources and support that you can get, other than from JBus, but from UGCS, because I think this is worthy of note. So there is incredible amounts of online support, and you can find majority of the manuals for the equipment online. And again, this is here. There is a very, very good wiki with a lot of I was asking questions the other day that I just didn't think it would find, but it did. I mean, it was pretty close, and I was then able to ask the next questions I needed to ask. So it was pretty good. There's lots of support that you can get on the website, just basic videos and tutorials, and also on their YouTube channel, which has got to be what I've, it's a really good YouTube channel, UGCS TV. Whether it's methane, whether it's magnetometry, whether it's Falcon on the M300, M300K with magnetometer, there will be a video there you can watch, get a feel for it. And then it gives you a visualization, so that when you talk to somebody like ourselves, like JBus, then you've got in your mind, you've got some kind of understanding of in your mind, in your right mind. And again, there are webinars as well, so not just nice videos and really funky music, I must admit, but also there are some really good webinars that you can, just like Coptrz do great webinars. There's some great webinars on from UGCS as well. So yeah, please take advantage of the online support. This will be, these links, we'll check these links, make sure they're all working for you. And this will be involved in included in a pack. So you can look at these a bit later. Just to end then, what I'm really keen on, since I've had this business, I've always wanted to really, it's about, I always wanted to do the right thing and not just be a reseller, not just solutions. not just be a reseller, but be a sort of a solutions developer and help companies commercialize them. I wanted to give a little bit more, and that's really how I'm trying to operate this. I like to have really close relationships. I have a really close relationship with Coptrz now, when we're talking through different sensors, and I know different customers, and we have sort of meetings together, and I get really involved. And I think that closeness is really important. The aim of the whole service that I'm trying to provide, both to Coptrz and yourselves, will be around giving you the information you need to make the right decisions for your business, and having you as an extension of our business, if that makes sense. Not making sure that we have that mentality. And as part of that, I'm really keen to make sure that you really do have a smile on your face. So it includes, making sure you've got all the training that's available, making sure that, if you need help, if you just need to ring up sometimes because you just want some technical assistance, I'll always try and help. Set up and configuration, and I've got it right there in front of me. Set up and configuration. First set up. If there's things that we can do to help your life easier, then we're going to be trying to be doing that. Trying to go through all the kind of practical tips like I've kind of briefly done today, and also making sure that you can almost stand on your own 2 feet. I'm not saying that we can provide you with all the information you need to go and use Magneto and Prism 2 and do, but certainly we should be aiming for you to be able to use those packages and be confident in using these packages, so that you really have got you've got a complete solution you can go to your clients with. And we do have other specialists that are in support of JBus, including geophysicists as well. So I say a geophysicist, but a very well known and good one as well. So we've also got that in the UK. So reporting and sort of like, how do you do this and how do you do that? It's taking data into, for example, into GIS systems, things like that, where we can just give you some help. So that's always there. And the last thing that I just want to mention is, like I said to you, I'm really, really hands-on. I was actually before I turned my hand to going into working for sort of like the Alstoms and Siemens of this world, I actually went. I did 6 years as a technical product manager for a company called Ratal, and I was actually involved in refrigeration systems. But it's very complicated. But what I did learn from doing that was that a lot of the people that kept coming back and were satisfied were the people that got the technical support during their got the demos, they got the trials, they got a lot of support during those periods where that's when they really needed the support. So that's an area that I'm really, really keen to be involved in. Where we can, I want to make sure that we provide a complete service, not just a case of saying, here you go, hand over, thanks very much, and we move on to the next. I don't want you to see us like that. I want us to see us very much in a partnership with you, like we're doing with Coptrz, and I think Coptrz share the same kind of approach to us. So that's just what I end on, sort of like my soapbox at the end of this talk. And yeah, thank you very much for listening. I hope you've learned something. I hope you've got enough of the branches from which you can start to hang some stuff that you can then ask some further questions and it's been really helpful. So thanks very much. And yeah, questions, James?
Yeah, brilliant. Yeah, thanks for that, Jonathan. There is a couple of questions. One I'll send to you after from Roger, which looks quite a complicated one, probably for the short amount of time we've got. But a quick one from Matthew, just regarding the echo sounder. Is that just a single beam, or can it support multiple?
No, that would be just a single beam.
Okay, no problem. I think the rest ones have answered. So, Roger, if you don't mind being patient with us, I'll forward that to Jonathan after this webinar, and I'm sure he'll answer that for you. But thanks, everybody, for joining us. Jonathan, that was a fully in-depth analysis of what you guys can offer, and some really, really great products there, which there's definitely a huge space in the industry for these kind of I suppose non-traditional sensors. Some people which might not have heard that you can actually put these these kind of sensors onto drones now. So definitely the future's bright for this kind of industry. And I'm sure you'll agree, Jonathan, that the interest in these kind of sensors are really quite high at the moment.
Very high, yeah. It's picked up. I can tell we're coming out of lockdown.
Absolutely. Well, thanks for your time, Jonathan. If anybody has any questions at all, or wants some pricing, or just a further little bit more of a discussion afterwards on how we can help, and I know, Jonathan, we're really keen to touch base with you guys and to take it to that next stage of how we can help as a business. But thanks everybody for joining us. Any questions, please let us know, and I'm sure we'll see you next time round. Thanks, everybody.
Thanks for everybody.